All right, so previously we talked about kinetics, which was how fast a reaction is going. And that's kind of talking about the beginning and middle of a reaction. Next up, we're going to move on to equilibrium. In this case, what we're talking about is kind of the end point of the reaction. So what we have to realize is that many reactions aren't kind of how we thought about them in maybe Chem 101. So, right, we say that we have A and then it turns into B. So all of A turns into all of B. But for many reactions, that's not true. What really happens is that A and B coexist at the end point. So A is turning into B and B is still turning into A. And even though you're at the end of the reaction, you still have both. And so what this double-sided kind of arrow indicates is that it's a reversible reaction. So while A can turn into B, B can also turn into A. And at the end point, we are at a dynamic equilibrium. And so what that means is that the rate of A turning into B is equal to that of B turning into A. And so the overall concentration does not change. And so while it looks like nothing is happening in the reaction because the concentrations are not changing, it's still important to note that things actually are still happening. So we can plot this if we think about it. So if we have concentration over here, and then we have A is our kind of reactant. So at the beginning, we're going to have a lot of it, and eventually it's going to disappear. And then B, we're going to have none in the beginning, and then it's going to appear. Oops, mix those two up. Should be B. This one should be A. And then we can think of another plot of rate of these reactions. And so when we're thinking about rate, at the beginning, A is decomposing very quickly, but then the rate eventually levels off. And then B is coming up very quickly, but it also levels off. And then after a certain point, our rates are going to be equal to one another. And when these rates are equal, we say that equilibrium is established. So overall, it looks like nothing is happening because the rate of the forward and the rate of the reverse are the same. And this x-axis here is time. So for example, think about our previous chapter, right? If we have some water and we cover the beaker with a lid, we have water down here as a liquid, and we have water up here as a gas, and they're turning into one another, but they're happening at equal and opposite rates, and so it looks like nothing is happening. Here's another example. So here we have this N2O4 turning into NO2, and as you can see, this N2O4 is colorless, while this NO2 is this kind of brown color. And so in the beginning, we're going to start the formation of our products, which we see here, right? This is increasing, this rate is increasing, but then after a while, we're going to reach equilibrium. And so you see these concentrations are no longer changing because the rates are exactly the same. And so another thing important is to realize is that the amount of reactants doesn't go to 0 and the amount of products doesn't go to 100%. There's still sometimes a mixture of reactants and products even at the end of a reaction.